Information processing is a theory and a framework aiming to describe how memories are formed and recalled. This presentation will outline 4 basic concepts: the basic information processing model as described by Ore, the dual coding model as described by Pavio, the distributed memory model as described by McClellan and Rummelhart, and the levels of processing model as described by Craik and Lockhart. The dual coding, distributed memory, and levels of processing models all fit within the basic model. However, each posits modifications to various aspects. We will look at the basic model as a whole, dissect the model into parts, followed by examining how each of dual coding, distributed memory, and levels of processing affect the basic model. Each model follows the same process, beginning with external stimuli, moving through sensory memory, through initial processing, into short-term memory. Rehearsal is an element of short-term memory. Elaboration and coding shift information to long-term memory, which can then be retrieved back into short-term memory. The final goal, of course, is output. As we progress in more detail through each slide, please note the diagram in the upper left-hand corner. This diagram indicates with a star our location within the larger model. External stimuli. External stimuli is information coming to us through the senses, typically iconic, visual, or echoic sound. For example, seeing a person that you know or hearing a language as someone speaks to you. Sensory memory. In order to process information, the first step in storing it, it must be attended to. Without attention, information will be lost in less than a second. Our senses are bombarded with information all day, every day. Most of what we are exposed to does not register unless our attention is focused on that particular input. Initial processing. Initial processing can take the form of attention, noticing and attending to incoming information, or automaticity, the opposite of attention, where information is overlearned and has become habitual. It does not require attention to be processed. Short-term memory. Short-term memory is also known as working memory. This is where information is actively processed, either through rehearsal or elaboration. Working memory only has a capacity of 5 plus or minus 2 items. Transfer to long-term memory can occur in 3 ways. Stimulus is an exact match to an existing memory structure. Stimulus is a partial match to an existing structure, in which case the structure is adapted. Or stimulus is not a match to any existing structure, and a new structure is created. Short-term memory is not only necessary for transferring information into long-term memory through elaboration and coding, but also for recalling that information when needed through retrieval. Rehearsal. Rehearsal is rote maintenance that simply retains information in short-term memory. Deeper processing is still needed for transfer to long-term memory. Elaboration and coding. Elaboration is necessary to code information to move it from short-term memory to long-term memory for long-term storage. Deeper elaboration leads to an improved chance at retrieval when needed. Long-term memory. Long-term memory is the permanent storage hold for all memory, perceptions, knowledge, and information. This is agreed upon. What is not agreed upon is how those memories are stored. Tulving identified episodic memory, memory for events, and semantic memory, abstract and general information. Hewitt and Abbott group episodic and semantic memory into declarative memory, information readily retrieved and voiced. Hewitt also adds imagery to the memory types. Abbott contributes procedural how-to memory. Long-term memory is not static. Information stored may be adapted, replaced, or expanded upon. Retrieval. In order for information to be recalled from long-term memory, it must be accessed. Theories on storage and representation vary. Collins and Loftus and Collins and Quillen suggest a network model similar to tabs in a notebook. New information can be added to the tabs. Tabs or information can move around. The linear nature of this model is problematic. Smith, Shobin, and Rips suggest information is stored based on defining characteristics. The huge number of stores required here is problematic. Anderson and Bauer suggest knowledge is stored based on verbal units. Later models move away from the serial processing. Output. Output is the result of retrieval and processing efforts. That is, once an appropriate piece of information is retrieved from long-term memory, it is brought back to short-term memory, where it is processed before an action or output occurs. Over time, various theorists have added to the basic model of information processing. We will examine 3 such theorists well known for their contributions to information processing: Pavio with dual coding model, McClelland and Rummelhart with the distributed memory model, and Craik and Lockhart with the levels of processing model. First, let's take a look at the dual coding theory as described by Pavio. The first difference or modification to the basic model can be seen at the external input point. Input is either verbal, logogens, or nonverbal, imagens. Different logogens and imagens correspond to each of the sense modalities. Dual coding also highlights methods of elaboration helpful to describe transfer from short-term to long-term memory. Strategies such as creating a conceptual peg to help elaborate on input and help create deeper connections. In this theory, children begin with only imagery. As language develops, labels are added and connections expand to create abstract representation. The composition of long-term memory also differs from the basic model in that long-term memory is comprised of nonverbal memory for things, imagens, and verbal memory for words, logogens. Representations are richly connected to each other as well as input and output functions. Systems can operate cooperatively or independently. Systems have cumulative effects on each other. For example, naming an object creates both verbal and nonverbal memory traces, hence dual coding. For retrieval in the dual coding model, verbal recall dominates some tasks while nonverbal recall dominates others. Enacting both systems increases the chances of effective retrieval. For example, the creation of a conceptual peg where, to remember word pairs, one creates an image, donkey hat, imagine a donkey wearing a hat. Imagery complements recall as it activates more than one modality. The next theory we'll examine is the distributed memory model as described by McClelland and Rummelhart. In this theory, external input is grouped together regardless of modality, information type, or other factors. Input is input. Distributed memory puts emphasis on the function of elaboration and coding. It posits that the creation of memory traces is crucial for later recall. The more ways information is elaborated upon, the more connections will be made. The structure of long-term memory is also distinct in the distributed memory model. It hypothesizes that memory is comprised of modules which receive input from other modules. Each module combines various sources of input. Modules are richly interconnected and many share partial overlaps. Modules are comprised of units, thousands to millions of them. Each module receives input and sends output from and to other modules respectively. Patterns of activation in modules reflect ways of knowing. As learning occurs, patterns of activations shift, altering the strength of connections between modules. This changes the memory trace pattern. In order to retrieve information from LTM, the pattern of activation must hit the right modules and units. Memory traces that activate even a portion of a pattern can result in retrieval based on the partial overlap of many of the modules and units. Each activation of a pattern modifies the pattern for future use. It is also important to note that in the distributed memory model, all modules are capable of input and output. The final model we will examine is that of levels of processing, as discussed by Craik and Lockhart. The first notable feature is a difference in sensory memory. Here, rates of forgetting are a function of depth of processing. No processing, no remembering. Initial processing is based on sensory details linked to the senses, such as lines, angles, sound, pitch, etc. Another notable point occurs at initial processing. Craik and Lockhart suggest that familiar input will be processed more deeply, more quickly. Short-term memory houses the next level of processing. It is an attempt to match input to already stored experiences or abstractions. This can be through pattern recognition or extrapolation of meaning based on previous learning. Short-term memory has a limited capacity. Information can be maintained here through rehearsal, but this will not code it for long-term memory. In the levels of processing theory, rehearsal performs a special role. Rehearsal holds attention on information, allowing for deeper processing. Information will only be stored if it is processed more deeply. If processing stops here, information will be forgotten. Two types of processing exist for the elaboration and coding of information. Type 1 processing is repetition. This holds attention. Type 2 processing is elaboration. This improves retention. Processing is not hierarchical. For example, type 2 processing may be the first and only type of analysis. Items in long-term memory have benefited from the most processing. Deepest levels of processing is semantic, meaning, and association-based. Only the end product of processing is stored for retrieval. Activation of LTM spreads. That is, one activation leads to another, leads to another, leads to another. The deeper an analysis, the more resilient the memory traces will be. Levels of processing also affect the speed and efficacy with which items can be recalled. Memories formed with deeper analysis will be recalled more quickly than those without. As processing levels are on a continuum, not a hierarchy, retrieval can occur at any level. Memory traces are a byproduct of analysis. Deeper analysis equals stronger memory trace equals better chance of recall. That is a brief introduction to information processing. The references as well as more information can be found on the host website.